Welcome back, Prealgebra students. We're in lesson 54, and we're going to talk about ratio and proportion first. So we remember the ratio is a comparison of two numbers. So if I said 1 to 2 or 3 to 4, 6 to 7, 8 to 9, 8 to 10, we know we would write that, like if I said 3 to 4, we would know we'd write that like this, right? That's what we usually do in math. Now, in language, we could write that ratio like this, right? We could even write it just like this. But when we do math, we like to see it in the form of a fraction. So we typically do this. So let me introduce you to something called a proportion. A proportion is a pair of fractions, which are ratios, that are equal to each other. And typically, it's an equality based on multiplying the original ratio by a certain number, or taking an original ratio that's large and reducing it to another number, reducing it down. So, for instance, I could multiply this by 3, and I could get 9 over 12, which is the same value as 3 out of 4. It's just been broken into smaller pieces here. Okay. Let me show you what I mean. If we have a box here, right, and we have 3 rows, actually, let me do a little bit better job with that. Haha, there we go. All right, if I have, let's do 4 boxes. That'll be a little bit easier. All right, so I have 4 boxes. That's the total number in the denominator. The denominator is always going to be the total number down here, right? 3 is how many we have. So we have this one, and we have this one, and we have this one, right? But now we need to have 12 pieces. We're going to multiply that by 3 to get 12 pieces. So what we're going to do is we're going to divide each row into 3 little rows. So 1 and 2 divides that into thirds. And then 1 and 2 divides that into thirds, right? So you could see we still have the same value that we have taken as our own, but now it's just in smaller pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And what we've crossed out for ourselves is 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's a visual illustration of what that looks like. When we multiply the top and the bottom by the same number, we are just breaking this denominator into smaller pieces, or into more pieces. Now, there's a way that you can check that mathematically and see if this indeed is equal to the original ratio. And the way we do that is cross multiplication. So all you have to do is you multiply the top times the bottom on both sides. 3 times 12 is 36, and 4 times 9 is 36. If they end up being the same number, then you know that these ratios are equal to each other, and this is a true statement. Sometimes we don't have all the information, and we have to find it within a ratio. Like for instance, we have a conditional proportion, is what it's called. A conditional proportion. That's where we're trying to find missing information within a proportion. So if we had 20 over 15, and that can be a proportion, the bigger number doesn't always have to be on the bottom. Sometimes it's on the top. That's okay. It can be an improper fraction when it comes to proportions. Just let it go. Accept it. And we have 4, but we don't know what this bottom is. We don't know what the bottom number is. We're trying to get back to this number here. The easiest way to find that number, the fastest way to find that number, is just to do the same thing we did here and cross multiply. So we take the top times the bottom and we get 20x on this side. And then we take the top times the bottom and we get 60 on this side, right? So what that does for us is it puts these two equal and makes sure that they have that equation between them, but then it gives us factors here. So having these two factors, 20 times x, and whenever you have a variable next to a whole number, it is multiplication. So 20 times x equals 60. That allows us to do the inverse operation and divide by the number we know, which is 20. So we divide both sides because it is an equation. It is, even though it was just two fractions, it's still an equation, and whatever you do to one side, you have to do to the other side. So we divide by 20 over here so we can eliminate it to leave x by itself, but we divide by 20 over here and we get 3, which allows us to solve the problem. So the proportion here is 4 to 3, 4 to 3, but we just multiplied and broke it into bigger pieces here so that it's 20 to 15. What number do you think we multiplied by? If you said 5, you are correct. So I'm going to put equals 3 right here, and then if I say times 5 times 5, 4 times 5 is 20, 3 times 5 is 15. And that's the other test. If you can multiply the top and the bottom by the same number, then you are correct. All right? That's another trick that you can do. That's also something that you can do if you forget temporarily how to solve. If you know that 20 divided by 4 is 5, right? Then you could say 15 divided by 5 is 3. And you would just divide both of these by 5 to find the answer. So 20 divided by 5 is 4. 15 divided by 5 would be 3. So if you can get there this way, that works too. The problem is you're going to be dealing with some really difficult numbers at some point, and it's not going to be so obvious. And you're going to have to rely on cross multiplication in order to solve your problem, because then you don't have to guess at what the divisor is. The calculator will tell you. All you have to do is ask it. You can say, oh, this is going to be divided by 20, so this has to be divided by 20, or whatever that number might be, and it's going to just give it to you. 60 divided by 20 is 3. Use your calculator. When it's big numbers, it's okay. All right? But this is what's called a conditional proportion, where we don't know one of these values. And whenever you cross multiply, we try to multiply such that x is on this side. If it's not on this side, that's okay. One of the other things that a lot of people do is whatever the numerator side is, that's where they put their answer. So 20 times x would go on the 20 side, and 4 times 15 would go on the 4 side. So that'll help you keep it straight by putting it on the same side as the numerator that you're multiplying with. All right then, let's move on to another one. Let me erase. Actually, I'm just going to see if I can move over just a little bit. There we go. That'll work. So 54, that was 54.1. Let's do 54.2. We have a conditional proportion here. 4 over 5 equals p over 7. We're going to solve for p. So again, we begin 4 times 7, that's 28, equals 5 times p, or p times 5, that's 5p. Okay, so we have our variable on this side now. That's okay. It's completely fine. We're going to divide to separate the p out by itself on both sides. That eliminates, that cancels. But we cannot divide 28 by 5, right? It's not divisible into a whole number. So we leave it. It's okay. Leave it like a fraction. In algebra, we would rather deal with fractions most of the time anyway, for the simple fact that as we get into higher and more complex numbers, they are easier to reduce. You can't really reduce a decimal, but you can reduce a fraction into something that's a little bit smaller and easier to deal with mathematically. It's also easier to factor when you compare numerators and denominators versus decimals and decimals. It's just easier to do the math with a fraction. So leave it in a fraction and leave it in an improper fraction. Get used to seeing improper fractions and accepting them. They're okay. They're numbers too. Let's love them as well. All right, let's talk about not proportion. Let's talk about some exponents and some radicals. So if you haven't written this down, do so now. I'm going to clear the page. All right. We have been evaluating exponential expressions. I think those are variables with exponents, where one of the numbers is represented by a variable. We know how to find the value of, like, if we said the index, third index of p, and we said that p is equal to 8, we know all we have to do is put 8 in for p. It's a substitution. So we would say the cube root of 8. We know we can factor 8 into 2 times 2 times 2. Well, that's 1, 2, 3. That's what we're looking for, is 3 of the same number. So the answer to this would be 2. Right? We know how to do that. So then that would mean that p would be equal to 2 once we solved the equation. The other thing we know is that if we were to say P3 and we gave p a value of 2, p equals 2, that p to the third would be 2 times 2 times 2, right? Technically, it would be 2 to the third. So all we did was we looked at our variable, and we looked at the number that represented the variable, and we just drop it in. That's all we have to do. Now, what I like to do whenever we have that, when we have a variable that we have to substitute numbers in for, I like to use what I call buckets. And it's just a pair of parentheses where you can write out the problem, and you put your parentheses in, and then you come back and you drop in the value of that number. And it makes it a whole lot easier, or the value of that variable. So let's do an example problem. We have 53 or 54.3, and it says to evaluate x to the y, right? If x is equal to 4 and y is equal to 3. So all we have to do is say, okay, here is x and here is y. So we have 4 and 3. So 4 to the third, you can do it on your calculator. I love my calculator. There's a little button on your calculator if you have a scientific calculator, which you should. X to the 3 means this to the 3, whatever's here to the 3. So you type in your number, which is 4, and you press this little button. There's your answer. How snazzy is that? So 64. Now you could do 4 times 4 times 4. 4 times 4 is 16, and then 16 times 4, that's 24. Carry the 2, 4 times 1 is 4, 5, 6. You could do it that way. If you don't have a calculator handy, I recommend learning how to use your calculator now, because one day you're going to want to take the ACT. And right now I am dealing with girls who do not know how to use the calculator because their parents said, do it in your head. And that's great for elementary. Up until about 7th grade, do it in your head, right? But when you hit pre-algebra, you need to start learning how to use that calculator, because it is going to be your friend when you need to get some speed for a test. All right. Now, if Miss Emma does not like for you to use the calculator in class, then you do whatever Miss Emma says, right? That is between you and her and she is your teacher. I'm just your video maker and a resource. Let's do 54.4. We have the square root or the squared index of p to q. P is equal to 3 and q is equal to 64. Ooh, we just saw that number. I think we know what the answer is going to be already. So we have p here, and because we already have this little symbol, we don't really need to make parentheses because we can just drop these in where they go, right? We already kind of have some type of a structure here to put our numbers into. So the cube root of 64, that's what we're looking for. That's what this means. So what number times itself 3 times gives us 64? We just did it in the previous problems. We already know the answer. We don't have to use a calculator. 4 times 4 times 4 gave us 64 in the previous problem. So we know the answer here is 4, right? But that's what this means. It's looking for the same number this many times to give us this product. All right, that is the last problem, the last example problem that we have for this lesson. I will see you guys in lesson 55.